We're solving problem 11 from the 2025 Amy 1. A piecewise linear function is defined by f of x and these two. I'm not reading that. And f of x plus 4 equals f of x for all real numbers x. The graph of f of x has the sawtooth pattern right there. The parabola x equals 34 y squared intersects the graph of f of x at finitely many points. The sum of the y coordinates of all these intersection points can be expressed in the form a plus b root c over d, where a, b, c, and d are positive integers such that a, b, and d have the greatest common divisor equal to 1, and c is not divisible by the square of any prime. Find a plus b plus c plus d. Now what we can do is we can just sketch this right here. So it's like looking about like this to the side, kind of like that. It's definitely not accurate. Mine is definitely not accurate. So yeah, but it's just going that way. So the main thing we want to do in this problem, well, we see that there are these upward and these positive and negative slopes. So our answer's gotta be something to do with that, right? We have to figure out something using those slopes. So I think the main thing I want you to see is you can utilize the positive and negative slopes to basically solve for the answer. If you have the positive slope, it starts right here at f of x, or no, not f of x, just y equals x. That's the first one. Then the second one, y equals, well, now the locator point is at 4, 0, so this is x plus 4, and then next one is y is x plus 8, and so on. Thus, what we can do here is, since we want to find the sum of the values of all these, we solve the system y equals x and x equals 34y squared, and use Vieta's formulas to get that. We basically just get that the sum right here is 1 over 34 for the positive. Now we can do the same thing when the slope is negative. The first one is y equals 2 minus x, then it's y equals 6 minus x, y equals 10 minus x, that says 10x, not 10 minus x, all the way until y equals 34 minus x, at which point the graph escapes from the clutches of the sawtooth pattern, I'd say. So we have this 34 minus x. Then what we do, we just do this again. Y equals, we solve y equals 34 minus x, and x equals 34 y squared. The sum right here is negative 1 over 34. Now, what we want to do is solve 34 minus y equals 34 y squared. We get that y is equal to negative 1 plus, we choose the plus option in this case, because it's a quadratic, but we want to choose the plus option, is 5 times root 185 over 68. Now, to sum up all these, we want to sum like everything up, all these positive and negative patterns, right? So, it's going to be 1 over 34 plus negative 1 over 34. That's the negatives, plus 1 over 34 plus negative 1 over 34, all the way until you get to this, negative 1 plus 5 root 185 over 68. Now all these terms are here, all these 1 over 34s, they cancel except for 1 over 34, at which point you add 1 over 34 to this, and that gives you 1 plus 5 root 185 all over 68. Now, it's in the form as shown here. We just have to sum all these up. So 1 plus 5 plus 85 plus 68 yields our answer of 259, and we are done.